Okay, so this is a presentation about leaf margin characters in bryophytes. And I put on the front cover or the front slide to acknowledge the source of the images here. Maybe I've got one of my own images in here, but I relied heavily on California mosses with those exquisite images, which are kind of perfect for this particular kind of talk, and then also the Big Green Book. And I think you will be able to tell which is which. There's a few other things that I source in there, but I decided not to put the source of all of these, so just acknowledging them up front. Okay, well, bryophytes, if you've got a leaf, you've got a big head start into identifying any bryophyte. Bryophyte leaves are very rich in the characters we use to identify them. There's the overall shape of the leaf, and not just the overall shape, but the shape of the apex and of the base. There's the size. They range from teeny tiny to, quite large. Integrity, that's whether the leaf is entire, which is the case in essentially all mosses, or lobed in liverworts. Lobing in leafy liverworts is a very important character, often at the genus, maybe even the family level. The contour, whether the leaf is flat or cupped or undulate or plicate, folded. Plicate and folded could mean the same thing, but in what I'm meaning here, many cases, in leafy liverworts, the leaf is completely folded back on itself. So it's folded almost like 180 degrees. So that's slightly different than a case where you have a plicate leaf with some ridges down the middle, little folds. The surface is also important, smooth, papillose, or with lamellae like sheets extending out for it. Cell differentiation, mosses often have a costa or one or more midribs in the leaf. Liverworts have specialized cells. They're often devoid of contents and much larger than the surrounding cells called ocelli. Then, of course, there's leaf shape, leaf cell wall shape, thickness, and in some cases, the chemical reaction of the cell wall with certain kind of standard chemicals is important. Organelles, really, I think the only organelle that's important in bryophytes are the oil bodies and liverworts, but they're very important at the genus and species level. And then margins, usually referring to the features of the outermost row of cells. And I'm not sure quite why I wanted to focus on margins. It must be sometime before I offered to do this that I was having trouble with leaf margin characters. And so that's why I thought I would explore this. Any of the others would be perfectly good topics, and maybe they're things we'll discuss too. So within leaf margin characters, we have what I've grouped as three main types of characters: the contour of the leaf, the and then projections. Contour, in many ways, is the simplest. Moss leaves are sometimes completely flat, but many times the margin is rolled in or involute, as in Weissia controversa, or it's revolute. Sometimes it can be kind of hard to see it. This is a fairly dramatically um, revolute margin. Sometimes they're curved in just a little bit, and sometimes they're irregular. So here's, oops, I'm sorry. Oh, I hate it when that happens. Um, in the case of this one, the Crocidium aberrans, the margin is revolute on one side, but not so much on the other side. So they can be irregularly revolute, and also in this case, it's revolute just by a couple of cells. Doggone it. Um, so in addition to the margin being curved or not, some leaves are bordered. That is, they have a thickened edge. And this might just be a one or two cells thicker, like in the second picture here in the Coccinodon calyptratus. You might not even really notice that, or you might think it's revolute. That's a place where you have to really do a section. It could be hard to tell whether that's just an extra few cells or if it's actually rolled slightly. But then you have a more dramatic case here in Schistidium rivulare, where you've got a couple cells wide. That's wide enough that you can almost tell that just by focusing up and down, although a section is always the best way. And then you have a very dramatic case in the California moss. It's not uncommon in California, scularia, where you have a great big old thick margin that's 3 or 4 cells wide. And here's the plant, and you can see you can definitely see something's going on that edge. So those are thick margin thickenings. And again, as inconvenient as it is, what you really have to do is section this to be sure about it. So then we get into another type of bordered leaves, which is when you have elongated cells along the margin that are quite different from from the cells that are more towards the interior leaves, and they form a what's called a limbidium, or they are limbate, which means that there are like, and you look at this niam, which is a picture from a photography contest. You see it has teeth, it has distinct teeth, but inward to the teeth are these elongated cells forming the limbidium, which is quite distinct from the more isodiametric or roundish or rectangular cells to the inside. Nobody could mistake that in a key if it says limbate. I think everybody would agree that it is. The Rhizonium glabrescens is still it's pretty distinct. I think most people wouldn't have any trouble saying that that's a limbate or a leaf with a limbidium. It's not always so easy though. Ticostemum, like in this Ticostum weigellii, it gets a little bit harder. And this is a place where I struggle a lot, whether the limbidium is distinct or indistinct or present or absent. You see the cells gradually get smaller as you move, or are shorter and more isodiametric as you move towards the center of the leaf, and along the edge they're longer, but it's a little less clear. And that to me seems like that's always what I'm finding, and I struggle with that sometimes. In which case, all you can do, and of course, it's going to vary. I'll mention this again and again. Depends a lot on who's writing it. It depends on what they're comparing it to. The only thing you can do in this case is look at as many different species as you can and see what that particular author is considering to be limbate versus slightly limbate versus barely limbate, or whatever other modifier they might use. Liverworts don't have many bordering things. There's a couple that occur in our area in the Rocky Mountains that do have a border on the cells. In this case, it's not a specialized type of cell in Solenostoma gracillimum, which is not uncommon at higher elevations in the Rockies in wet areas. The outer, it's very easy to see, even with a hand lens, you can see that the outermost row of cells is a little bit larger in this case and has a thickened wall, very distinct. Now, the one on the right, Scapania curta, is another montane, pretty common montane liverwort. And this is described as having it's being bordered by smaller, more thick-walled cells. I struggle with this all the time because this is the main feature that differentiates it from another species of Scapania, and Scapania mucronata. They can both have mucronate leaves, unfortunately, and I struggle a lot with whether or not this border, how much thicker it is. I've decided it's better to just sort of get a gestalt, look at it and then look away. If you look too long and too carefully, you begin to doubt yourself. And I could be wrong on this. Maybe this isn't what it is, but this is what I think represents the bordered leaf in Scapania curta. So moving on from borders, we get to projections, and this is what I mean by projections is a cell that sticks out from the margin, and this is where the fun really begins. So a margin with teeth along it will commonly be described as being dentate, and dentate means toothed. But then there's all sorts of gradations from there. Um, and a small tooth a leaf with large teeth along the margins would be dentate. Denticulate, they would be smaller. Um, and then there are other things that are used to describe it too. And the California flora calls the apex of Polytrichastrum alpinum as coarsely dentate, which really coarsely, how coarsely differs from large teeth or, strongly dentate, I'm not really sure. Um, and then, of course, teeth can also, there you can have one tooth. You can also, just to remind you, you can have double teeth, um, like in this Atricum selwynii. It's a pretty good tooth or pair of teeth. They're sharply pointed and very distinctly different. Then moving more to the middle of the slide, Dichodonium pellucidum is described in the California as being irregularly dentate. Those are distinctly teeth. They're smaller than in the other two that we've talked about. Um, and irregular, I don't know. I don't know if I would have called that irregular. I mean, they're mostly pretty regular. You see a few places where the tooth hasn't formed, but there's another area where irregular versus regular depends a lot on what it's being compared to. And you really want to do more checking than just rely on what strikes you as being regular or not regular. And then another point I like to make on this far right slide picture, it's Polytrichum sexangulare. It's described as being entire to obscurely denticulate. Now, when you look at it up close, you probably wouldn't say obscurely. It's pretty distinctly denticulate. It's certainly less so than Polytrichastrum alpinum. But I think here, if you take a slightly look at it from a slightly farther away view, if you look at the whole leaf, the leaf itself isn't, it does seem more like, obscurely denticulate. In this case, it'd be very helpful if they would give you a bit more information, as seen from what magnification. Is it dentate or denticulate? Because I can imagine going astray here. Because to me, I really wouldn't, if looking at the larger blow up, I wouldn't have called that obscurely denticulate. So something to be aware of. And then it gets more fun. Spinos is also used, and spinos obviously just means having spines, and spinulose would be having small spines. So the difference between a tooth and a spine. I mean, I think many might say a spine is composed of more than one cell, multiple cells. You think of spines in flowering or in like cacti or things, they're big projections. So in that case, in Pogonatum contortum, you might say that's definitely a spine. However, there are also some teeth that are, I mean, some things described as dentate that are multicellular. So it's a matter of degree, and it's again a matter of judgment and also perhaps comparison. Maybe it's more pointy than in some other species of Pogonatum or other species in a larger group, like in the family. But then you look in the middle here, this species is called Ephemerum serratum, but yet the leaves are being described as the margins as being irregularly spinos dentate. Now that one really, I mean, that one really throws me. Okay, yes, those relative to the size of the leaf, those are long spines for sure. What makes them spine and what does spinos dentate mean, really? I mean, I guess it means a tooth that's seeming like a spine, but I don't really know. I don't know how to interpret that. And honestly, without looking at it, I really would not know what irregularly spinos dentate. I see the irregular part. That's fine here. Spinos dentate. I would have a hard time justifying that. But anyway, and why not I mean, serrate means we'll get to serrate in a moment, but the species name is serratum, and at least on the left-hand side of the leaf, serrate seems pretty good. It's just over here they're kind of bigger. So puzzling and challenging. Serrate is a really commonly used term. I will say, I want to point out, just going back, that to their credit in the California flora, they rarely use the word dentate. They talk about teeth. They did talk about spinos. They use the word spinos dentate, but they usually talk about teeth or they talk about serrations. So they maybe, I don't know if that was an intentional effort to reduce confusion. But anyway, we get to serrate, generally described as having regular teeth like a saw blade where the teeth all point in the same directions. But it's a little problematic in the way it's used as well. Slightly cellulate seems okay. Very, very small teeth. They're all very regular though. Cellulate is used for Funaria muhlenbergii. Guess that's okay, but they're not really sharp. That doesn't recall a saw blade to me somehow. Piscometrium piriforme seems like a good bet for serrate, but doggone it, Timia bavarica, why is that not dentate? Or even spinos, if you get right down to it. It's multicellular. I mean, they're regular, I suppose, but dentate margin can be regular too. So that's a bit of a mystery to me. Then there are, you have to be careful sometimes that a margin can look like it's got teeth on it, but what it really is are projecting papillae from the cells. So the papilla, when you flatten the slide out, especially the thing gets flattened and the papilla, tends to go out. The papilla that's on the marginal cell tends to stick out. You have olecomnium palustri. You could still describe these as serrate, dentate, whatever. But it could make a difference depending on how the key is worded about whether those things that are jutting out are as the result of papillae or are they really teeth? And they may well have both. I think maybe Thioidium delicatulum has got both. Triquetrella californica, the way this picture was taken, you can't really see that those cells, you can't tell at all that those cells actually have papillae on both sides, but you see the papilla from the far side sticking out, giving it a sort of I don't know what you would call that, denticulate appearance, when what it really is the papilla sticking out. And then you got this wild situation where you have really fancy papillae in the cells that give you this odd, irregular margin appearance, as in this Incalypta on the far right. Now, in most mosses kind of stop with cilia, with teeth, that's usually things, marginal projections are either called serrations or dentations. But then there are cases where you have cilia on the margins, much more common in liverworts than in mosses. And a cilium is, I guess, really just a tooth that's gotten very long and gotten so long that it's a little bit wavy. And Tilidium ciliare on the left, a very common epiphytic liverwort in Eastern North America, is a good example of a leaf with ciliate margins. In the tropics, it's lots of liverwort leaves are ciliate. It's less common, not at all common here in the West. In mosses, we have Fabronia, um, which has in several species ciliate margins. And then you got an interesting case in this Helodium blandoii, which has cilia, but they're actually in some cases branched, and they're at the base of the leaf. And so those are often referred to as paraphilia rather than cilia. But honestly, the difference between a cilium and a paraphilium is really just about branching, I think. I always think of paraphilia as mostly on stems, but if you can have paraphilia on leaves, as they're described in Helodium blandoii, then really it's just different because it's branched. So it could be called a branch cilium if you wanted, but that's not so commonly encountered. And then you get really fancy, you get into divisions that are toothed and often then cut, deeply cut. So laciniate is deeply split or cut into narrow or fine irregular divisions with taper pointed incisions or pointed or lobes. And this describes the genus Trichocolea, which is a worldwide genus. It doesn't occur out in the West, but it does occur in the East Coast. This picture happens to be from a New Zealand one, where you have these sort of lobes or deep cuts and then cilia off of them. And then a rather rare liverwort in Eastern North America is Lophocolia muricata, which also has a cuts in the margin, not very irregular, not really like lobes, although they're sort of like lobes, and then it has cilia along the edge. In mosses, the best example I could think of something like this is the is it the branch the stem leaves in Sphagnum fimbriata, where you have fimbriate is sort of a extension of laciniate in a way, but here the what happens is the cells die, the cell contents die and break down and just leave the edges, which gives it kind of a fringed or yeah, fringed appearance. Fimbriate. Fringed and fimbriate mean the same thing, but it's not a common situation to find in mosses elsewhere. And then crenulate. So here we have, instead of pointy things, we have rounded things. And in many liverworts, it's really nothing more than just a cell that's quite a marginal cell that's quite round and sticks up. But in some mosses, like for example in Polytrichum juniperinatum, there's really a rounded kind of knob on the edge, which is a good example of a crenation. Um, but they can also be a little bit irregular. This is Dicelium nudum. It's described as being entire or crenulate above. You see, just a little bit bumpy. Um, and again, if with papillae sticking off the edge, Incollepta intermedia is described as crenulate papillose. Um, I'm not sure what's going on in Andrea rupestri. I guess it's really just sort of cell wall thickenings, very thick-walled cells that are making those crenulations. I don't usually have too much trouble with crenulate. That's not a particularly hard one. Um, but then I don't know. I couldn't find any examples of this in mosses, though I suspect it exists. But another type of edge, the last one I'm going to talk about, is eros, which means like chewed, eroded. Eroded and eros would come from the same source. And that's a very common way to describe the leaf margins in the cute little liverwort known as Chylocyphus minor, which is very common here in Colorado. And it's really eros because of the gemmy, the light that you see on the margins, you see these light green sort of outline to the leaves. Those are the gemmy, and they give it kind of an irregular appearance, but when they fall off, when the gemmy, they leave a leaf that's kind of tattered along the margin, and that would be what we would call eros. So I thought it might be fun just to finish up to see what you would think. How would you describe? Any thoughts on the New Zealand Physidans, on how you might describe the margin? Anyone? There's no right or wrong answer. It's not like I'm going to compare it to something. I'm just curious what people think.
Crenate?
Could be crenate.
Possibly. From a distance, it's going to look real smooth, I'm thinking.
Mhm. Yeah, probably does. A little bit pointy. I guess I wouldn't balk at denticulate.
It's kind of
That's a
crenate
smooth
to
crenate.
Crenate
denticulate.
is better
Yeah.
though, I think. Yeah. Okay. What about Codriophorus nourricii?
Rag.
Non-entire.
It's definitely irregular. So
Yeah, definitely irregular.
yeah.
Ragged.
I, yeah, I don't know if I would call it eros.
No.
Well, ragged's kind of good. That implies non-irregular or non-regularity.
Yeah. But ragged, yeah, okay. Other thoughts?
Would those tips be papillose? They're
Uh,
kind of whitish, they're
they
discolored.
do. You're right. They do look like, but that's probably the preparation rather than anything else. It's probably not a papilla.
Okay.
Liverworts will sometimes have papillae on the edge of the leaf, but not so common in mosses. I think it was described as irregularly denticulate. And the one on the right is a little harder to see maybe, but this is the same thing. There's the leaf up above is the whole leaf and then a close up down below. How would you describe that?
Well, they look like teeth,
Yeah,
Hmm.
they do.
but they
Yeah, I
look
don't
like
know
some are multicellular.
yep.
Hmm.
The
So
boundary
that'd be a
between
spine.
is fine. Yeah.
Go ahead, Andy.
So say it's on the edge there between what I would call a spine versus a tooth,
Hmm.
but definitely multicellular.
Yeah. I think the take home message is, I mean, when you're keying out, all you're at the mercy of whoever wrote the key, and you just or the work, the descriptions as well as the key, and you just have to get to learn how that individual characterizes things. If you're ever in a position to write your own, though, I'd say avoid words like dentate and serrate as much as possible and describe what you actually see. Small regular teeth, unicellular teeth, all pointing, towards the leaf apex. It's more words, and that could be a problem depending on the format of what you're writing. But unless you're going to take the time to really define what you mean, you can see that there's a whole lot of room for interpretation. Any questions? That's the end of my presentation.
Oh, that was super.
I
Thanks,
can ask a
Barbara.
dumb question. Do they
Sure.
ever have hairy margins? How would you
Harry.
distinguish a hair from a tooth?
Huh. Do liverworts have hair? Do bryophytes have hairs? Well, they have
I
hair
I have
points.
no clue. That's
No,
why
I mean, you
I
think
asked.
of a hair as like a dead cell that projects.
Well,
Well,
the calyptras are often
yeah,
described as hairy, like in the orthotrichums.
right, right. Leaves don't have hairs, though, really.
No.
Well, you were describing one margin as fimbriate, and
Yeah, yeah.
and it had long, elongated
Mhm.
teeth that were
Yeah,
very narrow. And some the sphagnum you showed looked like it was really hairy.
it does. I mean, it's
It's
really,
just the appearance.
yeah. I think words get used traditionally in fields,
Right.
uh, and that's what it reflects more than any real definition. I mean, I can certainly think of some tropical liverworts with fabulous long projections that you might call hairs. You'd be well within your rights to call them a hair. Um, so it's just not really used. Any other questions? Okay, thanks. I'll turn
Thanks,
this
Barbara.
back over I'll stop the share.